All right, we're going to look at solving a system, this time with matrices. Matrices make it a little bit easier for us to eliminate the variables and move towards a system or a situation where we can easily read off or actually find the values of each of the variables that solve the system. So here we have a rather large system. This is a system of 4 equations, or 4 variables and 4 equations. Let me just read it here. So this first equation is 3w minus 5y equals negative 23. W minus x plus 3z equals 14. Negative 3w minus 3y minus z equals negative 13. And x plus 3y equals 9. All right. To solve the system, if we were to try to eliminate the w's here, as it stands, it might be difficult to do that because first off, it takes up so much space. We have so many variables, and then there's these empty gaps here where there's no x or z in this first equation. That's just ripe for error. So what we'll do is we're going to convert the system into what's called an augmented matrix. An augmented matrix simply takes just the coefficients of the variables and then the constants on the other side here and writes in a very nice clean format. So let's do that with this system. So the first thing we need are some brackets, and then we just list the coefficients, starting with the w, so the variable w. The next column will be the x column, y's, z's, and then the constants. Okay, so 3, 0, negative 5, 0, negative 23. Okay, so I've written the coefficients in alphabetical order, the variables here. So 3, 0, because there's no x in the first equation. Negative 5, 0, because there's no z, and then negative 23. All right, let's do that with the other 3. So we have 1w, negative 1x, no y's, 3 z's, and a 14. We'll have negative 3, w, 0, x, negative 3, and y, negative 1, z, and negative 13. And then finally, no w's, 1x, 3, and y, 0, z, and 9. Okay, we usually put a dotted line here to separate the coefficients from the constants, and then we'll close the matrix right here. So this is an augmented matrix. I mentioned this is the coefficient matrix. This is the coefficients of all the variables. And then we have the little divided line here. This is the augmented part of the matrix. This would be the coefficients, and this is the part that is what's on the other side of the equal sign. So these constants over here. Okay, now what we're going to do is we're going to apply a series of operations called row reduction. And so we're going to get this to look like what's called row echelon form. And what row echelon form is going to look like, so here we have an augmented system. We've got some numbers over here. Right. What we're going to have is a 1 in this position, maybe some numbers over here, zeros below it, and then stuff out here. So what we'll have is like a diagonal shape right here of coefficients with the zeros below it. That's what our goal is. So the first thing we're going to do is try to get 1s in this column. So this should be a 1. Everything below it should be 0. And then this should be a 1, or if it's convenient to do that, we'll make it a 1, and zeros below it. This should be a 1 and a 0 below it, and this should just be a number. Once we have it in this form, we'll be able to read off the z. This next one will allow us to read off the y and or will allow us to find the y because we will have the z at that point, and we can continue up the matrix collecting the variables until we have them all. We'll have a point for the solution. Okay. The way we go about putting this matrix in this form is the method of row reduction, and it's very similar to the elimination method. We're going to multiply a row by something and add it to another row to eliminate one of the coefficients, make it 0. Okay, and there are some rules that we can use to do this. A few of the rules, we'll just write them down over here. One thing we can do is we can swap two rows. The order in which we were given this system doesn't really matter. We could swap and interchange two of them anywhere. It doesn't matter. 2, we can multiply a row by a number. Non-zero, of course. And this is because these are equations. We can multiply both sides by some number. We will not change the solutions. All right. 3, and this is the one we'll use most often, we can multiply a row by a number and then add it to another row. By a non-zero number and add it to another row. This will replace that row in the table, and this is how we will go about eliminating the coefficients. All right, so let's go ahead and get started. We'd like to have a 1 up here in the upper left, and we notice that the second equation has a 1 right here. So we can use the first property here to just swap the second and the first row. So that's what we're going to do. So we have 1, -1, 0, 3, 14, and then 3, 0, -5, 0, -23, -3, 0, -3, -1, -13, and this last right here, 0, 1, 3, 0, 9. All right, so now we have a 1 here, and this is advantageous because now we can use the third property. We'll just multiply this first row by whatever we need to eliminate the W coefficients from all this entire column below it. So the second row here needs a -3. So multiply. So we're going to take this first row, 1, -1, 0, 3, 14. And what we're going to do is we're going to take -3 times the first row and add it to the second row. And that will go in right here. Okay, so let's do that. -3 plus 3 is 0. -3 times -1 is 3, plus 0 is 3. -3 times 0 is 0, minus 5 is minus 5. -3 times 3 is -9, plus 0 is -9. -3 times 14 is -42. And then we add that to 23. So 65. Yeah, that's right. -42 and -23, 65. -65. All right. We can also, since we want to eliminate this -3 as well, we'll go ahead and multiply 3 by the first row and then add it to the third row and replace the result right here. So 3 times the first row, we get 0. 3 times -1, this one is -3. 3 times 0, doesn't change anything. 3 times 3 is 9, -1 is 8. And 3 times 14 is 42, minus 13 is 29. Okay, and this last row has 0, so it's good. 0, 1, 3, 0, 9. Okay, that's a good first step in putting this in row echelon form. We have a 1, leading 1 right here, and zeros below it. We'll now turn our attention to this coefficient right here. All right, we've got a 3 here, a -3 right there, and then a 1. I think the 1 is advantageous, right? Because we'll be multiplying this by some number to eliminate these coefficients. So let's swap the rows, 4 here and 1. So 1, -1, 0, 3, 14. We have 0, 1, 3, 0, 9. And then 0, -3, -3, 8, 29. And 0, 3, -5, -9, -65. Okay. Now we need to eliminate these values, -3 and the 3. So we'll multiply the second row by 3 and add it to the third row. So 1, -1, 0, 3, 14, 0, 1, 3, 0, and 9. All right, and now we take 3 times row 2, add it to row 3. Okay, so we've got a 0 first. 0. 3 times 3 is 9, minus 3 is 6. 0, still 8. And then 3 times 9 is 27. And 27 plus 29 56. Okay, and we need -3 times row 2 plus row 4 to eliminate this 3. So we'll have 0, 0. We have -3, which is -9, plus 5 is -14. 0, minus 9, and then -3 is -27, minus 65 is -92. Okay, so once we have eliminated the rows here, went ahead and filled out the next step, and that was to get opposite coefficients in the y variable. So this 6 and this -14, we need to make those opposites. And it would be tough to divide by 6 here to get 1, because then we'd be dealing with fractions, and we want to avoid that as much as possible. So the least common multiple of 6 and 14 happens to be 42. The 6 is lacking a 7, and the 14 is lacking a 3. And so I went ahead and multiplied the third row by 7. So that's 0, 0, 42. 7 times 8 is 56. And 7 times 56 is 392. We multiply 3 by the fourth row. 0, 0, -42, -27, and -276. All right, now that they have opposite coefficients, we can add the third row to the fourth row, and we'll get this eliminated. So at the top here, we'll have 1, negative 1, 0, 3, 14, 0, 1, 3, 0, 9, 0, 0, 42, 56, 392. And now we take row 3, add to row 4. 0, 0, 0, and then 56 minus 27 is 29, and 396 minus 176 is 116. All right. Now we can take this last row and divide by 29 to make this a little bit easier to solve from here. So 1, negative 1, 0, 3, 14, 0, 1, 3, 0, 9, 0, 0. Let's see, we can just go ahead and go back to this one. We can divide by 7. So 1/7 row 3. It'll go back to being 6, 8, and 56. And then we'll divide by 29 times row 4 to get 0, 0, 0, 1, and 116 divided by 29 happens to be 4. Okay. And so this is a row echelon form. You can see we have zeros, kind of a triangle here, and then coefficients right here. That should really be a 1, but we won't worry about it because we'd have to put fractions in there. The advantage of this method is we now have a value for z. Remember, this last column is the z column. So we have a value for z. Z is 4. All right, and now the second equation, the second one here, says that 6, so this is, we'll write them up here, is w, x, y, z. So 6y plus 8z, we know what z is, equals 56. So 6y plus 8 times 4 equals 56. So 6y plus 36 is 56. Subtract the 36. We get not 36. 16 plus 16 is 32. And subtract that, we get 24. And so y equals 4. Aha. So z is 4, y is 4. We can go to the third equation now, which is x plus 3y equals 9. We know y is 4, so x plus 3 times 4 is 12 equals 9. X is negative 3. And then the last step here, we have 1, or x, w, sorry, not x, w, minus x, which we know, plus 3z equals 14. We have a value for z and also for x. So w minus a negative 3, so plus 3 times 4 is 12, equals 14. So w plus 15 equals 14. So that means w equals negative 1. All right, so w, x, y, z. Solution, negative 1, negative 3, 4, and 4.